So it's necessary to learn classical control before automated control. Yeah, definitely. Get your basics down. Get your foundations down. Is this a logic simulator for relay logic circuits? It is, Mikester. Yes, it is, mate. Yeah. Danny Sav is great at his job. Well, we'll see. This is his first time tonight. Nah, I'm sure he'll be good. Yeah. What software? This is Simu Relay, mate. Welcome in, everyone. We've only just started. Now, I mean, to connect from your laptop to a PLC remotely, what's that process look like? So just hooking up with your laptop to a PLC? Is that what you're saying? I can't show you Siemens, but I probably could show you Mitsubishi. I might need to start it up, though.
Control. You must bring control.
William G, thank you for the follow, mate. Really appreciate that. Excuse me, I've got like a sore throat today. Let me just see this. Oh, through a VPN. I can't really show you that, to be fair, mate. I haven't. You'd need something like a Teltonica or what else? Like a NetBiter or an E1, something like that. Can you import safety relay logic? Into what? This software, do you mean? Used any SU drives or motion controls? I've not, mate. No, pot of mouth, I haven't. Sorry. I thought I'd load up one of the previous drawings I've done. Well, circuits I've done for a video about a year ago. It was a long time ago. But I thought it'd be interesting to show it.
Control. You must bring control.
Excuse me, everyone. Let me see if we can do this. Choose that. Use. There we go. Yeah, so this circuit I've put together is basically a bit of a trick you can do to get 7 outputs from basically 3 outputs on a PLC. And it's basically using a clever way of connecting up some relay contacts. Not sure what's going on there. TikTok's giving me some messages. Anyway, yeah, so I've put together this circuit to basically show turning 3 outputs into 7. This is Simu Relay. Yeah, cheers, Danny. Thank you, mate. Yeah, so how it basically works is using binary. So if I turn on this bit here, you can see we get a 1. If I turn it off, we get a 0. If I turn this one on, we get a 2. If I turn it off, we get back to 0. If I turn both of them on, we get a 3. Does everyone see how that's working? It's kind of backwards because binary normally starts from the right, but it's just kind of the way I drew it. And then if I go to this one, we get a 4. And if I want a 5, I'll put this one on. If I want a 6, I take that off and put that one on. And if I want a 7, I put all of them on. Hey, Professor Butler, welcome back, mate. New York, nice. What's the weather like there this time of year? Can you just use Arduino? You can use Arduino with OpenPLC, and you can do some like ladder logic and that sort of thing with that. This is just some simulation software for circuits and that sort of thing. Relay logic, timers and that sort of thing. Do you have to comply with IEC 62443 or the standards I work to aren't that one. I'm not entirely sure what that standard is. I tend to work to 60204, I think the number is, and the number escapes me. There's 2 that I mainly work to, and it's basically the standard for rotating machinery controls and the standard for LV switchgear and control systems. How's everyone doing tonight? So yeah, anyway, this is basically a 3-bit and it gives you 7 outputs circuit. That's basically what it is. So you can see as a flick through, you're always getting a different output on. So this could be, these 3 switches that I've got here, they could be outputs from a PLC. And then you wire them up to some relays. You do a little bit of clever wiring together, and you can get basically 7 outputs. You can never have all outputs on at the same time. It's only ever one at the same time. But yeah, neat little trick. Right, okay, so nice cool day, 10 degrees with some overcast clouds. Yeah, it's been pretty chilly here today, to be fair. I'm not entirely sure how cold. I ain't got my phone with me, but yeah, it's not been the warmest. It's definitely cooled down in the last week or two, and the nights are getting dark as well, and the mornings are dark. Right. So next, don't want to save that. Let's close that down. Make that a bit smaller. I put together a circuit the other day. I wonder if this will open. Ah, here we go. There's some sort of cascade of switches. That's right, mate. Yeah, with that one, you just did a bit of cleverness with the contacts, and you could essentially get 3 relays to give 7 outputs. And if you programmed your PLC to, you know, give, it's mainly used for, like, I don't know, you've got different modes or something like that. You want to save on some outputs. You can tell what mode you're in, because you can only have one output on at once. You can't have multiple outputs on, so it's useful for that. I put this one together the other day. This is a bit more what I do at work. This is a bit more power generation type stuff. I don't know if anyone's aware of what an ATS is, automatic transfer switch. But I'll play it for you. You can kind of see how it works. So if I turn that on, 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 and turn that on, you should, I think, be able to see this okay. So what we've got over here, if I zoom in, we've got a main supply coming in. Don't worry about this. This is just for the simulation. Main supply coming in. It comes through this contactor. Again, don't worry about this contactor. It's purely for simulation. The first thing it will do is come to the circuit breaker. So through the circuit breaker, you then go into a contactor and out to your site load. And most buildings that have ATSs, all their building will be supplied from up here. All their site loads, you know, whatever distribution boards and stuff they've got. And it'll just sit like that forever, until the day the mains fails. So that's what this switch is over here for. This is a mains fail switch. If I fail the mains, the building's no longer supplied. But what I've got going on down here is some circuitry to basically start a generator. And that generator starts, gets up to speed and volts, and then closes onto the building. You would use ATS panels to supply things like lifts and smoke ventilation. You would, mate. Yeah. It's basically an ATS is you use with them wherever you need a backup supply, and you don't need it to be like a synchronizing supply or anything. It's just a brake changeover. So yeah, that's done. Just it's as simple as it gets, really. It's using hardwired timers and relays. Don't mention STS switches. STS? Are they the solid state ones that like synchronize and that sort of thing, or very fast switching? I'm not familiar with the term, David. Go to work and it's dark. Come home and it's dark. Winter, eh? I know, mate. Tell me about it. It's depressing. It's really depressing. I miss summer already. Yeah. So at this point, the mains has still failed, but the building load's been supplied by the generator. So we have this second source of supply, and normally it's just a backup generator that's sat there. Static transfer switch. Yeah. You get them on UPSs and that sort of thing, don't you? We've got a couple of lamps just to tell us the status. These would normally be on the front of the control panel. We miss summer but complain when it's hot. You're right, I do that as well. You are right. The thing is, I don't like the hot weather. I just like the long days and like bright mornings. Yeah, so we've got some lamps to tell us the generator's available, the gen's on load. If I bring the mains back now, we've got a little bit of a mains return timer. It's just ticking down here. And once that goes, this contactor will open. And then this contactor will close a couple of seconds later. There we go. Back on mains. Generator runs down. Appreciate that, Danny Sav. Thank you, mate. And there we go. So now we've got the mains unload and mains available. The mains unload and the gen unload, they're just basically directly driven from the contactors. So whichever contactor's closed, the lamp will light up. The available one is if the supply is present or not. So if that supply is present, which it is, then we get this lamp on down here. And the same for the generator. Yeah, anyone got any questions about it? It is holding main contactor all the time. It is, mate, yes. So there's a lot of different ways of doing this. It is quite common to have just contactors, so the mains contactor is just always closed. But you can have a motorized switch, or you can have MCCBs or ACBs. You can do it that way. But it is quite common for smaller stuff to just be on contactors, yeah. But the wastage, you know, the energy you're using for the contactor is totally minimal compared to the rest of the site, you know, rest of the building load. So it's a little bit inefficient, but it's not too bad. What else can I show? Well, I'll show it again. You can see the way the circuit works this time. So there's a bit of a generator start delay. That's a bit of simulation just to simulate the generator starting up. Once it gets its supply on, you see the gen available light came on, this relay energized. There was a bit of a timer, then it closed up the contactor. This KM1 contactor, that de-energized straight away and it lost supply. Second timer on reinstatement to mains longer wait time. Yeah, that's this timer here. Normally it'd be like 60 seconds or more. You know, it could be quite a while. You don't want to go back to your mains if it's unstable. You want to make sure that mains is solid before you go back to it. I've just set it to 10 seconds, so we're not all waiting here. Wish Simmer Relay have a community group. Can you see how this stuff works? Hey, join my Discord, mate. My Discord. I haven't really. I've only just put it together. Really, I haven't built it properly, but that's the plan. The plan is to have a little bit of a community going. People can share their Simmer Relay, you know, circuits and stuff like that. Talk about controls and that sort of thing. I think the link is in my bio. Not entirely sure. I feel like I have to refresh it every couple of days. Just type in. You can search, I think, or look on my bio. It's called the Automation Hub. I only just built it, to be fair. There's not many people in it at the moment. Okay, so yeah, that's the mains return timer down there. And if I bring mains back, you'll see that ticking down. So it stays on generator until you're happy the main supply is solid again. And once you're happy, just basically set by that timer, it'll open the generator, close the mains, and generator shuts down. Appreciate that, Adam. Thank you, mate. I mean, because of heating coil and stuff. Yeah, I mean, the coil will be rated to just be continuously on. It wouldn't be a problem. Right, okay, so... yeah, any more questions about that, I guess? Does anyone work with ATSs? I guess that's one question. You know about how this stuff sort of works. Nowadays, we wouldn't really do it hardwired like this. I get the occasional customer that asks for it to be hardwired. They just want something super simple. They want something that if it doesn't work right, that they have the knowledge to be able to fix it. Nowadays, we'd use a controller like a Deep Sea 334 or a 335. You might use an ABB True one. You might use a Socomec motorized switch with the controller in it. Nope, never. Interesting to see the wiring behind it. Yeah, it is. This one's really basic. There's not. It looks worse than what it is, I think. But if you had to play with it, you'd probably realise how it works, really. You did it for a small gas generator. Yeah, that's where they're mostly used. They're just the smaller sets, small building loads, that sort of thing. The bigger buildings, they don't use contactors. They will use like ACBs or MCCBs or a motorized switch, like I mentioned. And even, you know, I guess higher sites with a bit more critical loads, they would use a synchronizing system. Socomec is the normal go-to. Yeah, we build panels with Socomec in all the time, yeah. I prefer to use a Socomec remote switch, which is without a controller, and then we'll put our own controller on using a Deep Sea controller. Because the Deep Sea 335 is pretty good. Yeah. I was having a look the other day at all the little circuits I've saved over the years. For no real reason other than just to probably look back at them in time. So let's have a look. What else have I got? A DC motor starter. Don't really remember what this was. We looked at this sort of thing that, you know, the last stream and the stream before. There's nothing really to that at all. It should try to start generator 3 times if it lacked fuel. The way that circuit worked was basically, let me go back to it. That one there, sorry. So the way this circuit works is the KM1 contact here, that would just be normally it'd be a changeover contact rather than just normally closed, and you'd wire that to your generator controller, and the generator controller does the 3 attempts to start. This thing would just remain closed for as long as the mains breaker's open. The generator controller tends to do the 3 attempts to start. But you're right though, that is a thing. Because after 3 attempts of running your start motor, the likelihood is your batteries are quite low. You can maybe get 6 attempts out, but more often than not, your battery voltage is going to be flat by the time you've, you know, done a ton of starts. I can't pronounce your name, but I'm going to call you Hee. Thank you for the follow, mate. I really appreciate that. Sorry, you probably answered this loads of times, but what software are you using? This is called Simu Relay, mate. You'll find it on the Microsoft Store, Google Play Store, or the Apple Store. Ralph Salmon, thank you for the follow, mate. Really appreciate that.
You must run control.
Appreciate everyone who's joining, liking, and all that stuff. Yeah, so that was that one. What else did I have? What else can I show? Can I show this? This was for a job. I'm gonna show it, but if there's got anything to do with the job on there, I might have to close it down. Oops. I can maybe show this. I can't really remember how it worked, and it's not drawn very well. In fact, I'm not entirely sure what's going on at all there. I feel like the software's updated a couple of times since I did this, so that's why these wires are all looking a bit weird. Let me fix it a little bit. This was basically some fuel control. As part of the control panel, I had to do it all in hard wiring, and before I sent the drawing out for build, I tested it all in here. But I don't remember it looking like this. So I feel like because the software's updated, it's changed it a little bit. It all looks a bit strange. Like, why are these wires overlapping? I wouldn't have done it like that. Daddy Cool, thank you for the follow, mate. Really appreciate that. Let me just fix this. It annoys me a little bit when I see the wires all like that. Oh. Let's run it and just see what it does, because I can't really remember myself. In fact, just before we do that, let me fix that. Guest, thank you for the follow, mate. Really appreciate it. And Mary Bakes as well. I didn't miss that. Thank you for the follow. Can you all see that alright? I feel like you can. Yeah, the wiring's gone mad. Come on. There we go. Don't know why there's 2 there. Whatever. Let's give it a run and see what it does. Ayo, thank you for the follow. I really appreciate that. You're installing it. Yeah, this program's free. This program's totally free. I say totally. There is a caveat to that. You don't get the timers. Let me see if I can pull that across for you. The timers here, you don't get those. That is a small fee. But the rest of the stuff you get is fine. It's totally usable without the timers. I guess it just depends what you want to simulate and build. I think it was about £10 for me. Can't really remember. Yeah, have a look. Like I say, it's not necessary. You don't actually need them. Let's give it a run anyway. So, can I remember how it worked? I feel like there was a few... Okay, so... There'll be a fuel low level, low level, high level, high level. Do I have to have them 2 on? Thank you for the follow, guys. Jerbear, Chemcuber, user with a load of numbers. Thank you for that. Which application are you using? This is Simmer Relay. So the comment's pinned. Have a look at the pinned comment. Cheers for that, Danny Sav. Full Pro version is £15, which isn't bad. It is not bad at all. And like I say, you don't have to have it. You don't have to use it. It's fine. Bean Machine, thank you for the follow. Really appreciate that. So, yeah. Let me just figure out... Because I made this circuit maybe like 2 years ago. I don't fully remember how it works. It's probably similar to what we've discussed on a previous stream. Can you guys see them switches? No. It's because it's just out of reach there. I'm just making sure you can see the position of switches, which is down here. If you look in the bottom left, you'll be able to see. Okay, so this is automatic mode, I believe. There were some valves involved, I seem to remember. We don't need to do any of that. They're all alarm stuff. Valves, there we go. Let's turn them off for a sec. We've got a pump start on. That's probably to do with me. If I put the high on, will that go off? Yeah. So, on this, it must have been the low switches were make on rise. On the high switches would have been make on rise as well. So, the sort of center of the tank was without any... make on full, sorry. The low switches would have been make on full, and the high switches would have been make on rise. So at the mid level of the tank, there wouldn't be any switches closed. There were some valves. Let me just close that one. Leak detect switches, bond switches. They're all shutdowns. That's what all this stuff here is doing. What we got down here? Can you guys see that right? Yep. Can I build schematics with cell relays and see how it all operates? You can't, mate, because you would need a cell relay to actually see the, you know, when you're closing a relay contact or something, you don't have the cell relay to be able to see how that affects the relay. This is just hardwired, so timers and contactors, relays, that sort of thing. Alban, thank you for the follow. Really appreciate that. So, right, we're still going on. I'm just trying to get my bearings with how this worked again. So the valve's closed. I think if we got a low fuel level, it would start a motor. It did. Oh, and there's a changeover of the motors. So if I put the high on, we'll be able to see that it goes off. And if I put the low on again, it changes motors. You see that? Changes pumps. So there's a bit of changeover with that. You're welcome, mate. You're welcome. No problem. So the pump really shouldn't. I mean, I don't remember what stage I built this circuit and simulated, but I seem to remember from the job, the pumps never ran unless the valve was open, which it isn't doing at the moment. So if you got a low fuel level, in fact, we'll probably be able to see it down here. There'll be a valve open relay. open valve KM1. So I guess if I get a low, let me see if you can see that. If I get a low up here, yeah, you can see that. It energizes the open valve relay. So that valve that was closed would then go into open. The pump would then start because I guess we've got a pump start on. And the pump's running. Nick, thank you for the follow, and Slates, thank you as well. Really appreciate that, guys. So yeah, the pump's going, the tank's starting to fill up, and then eventually you would lose your low. Well, I put the low on, but the low or the low does the same thing. You would eventually keep going, and the pump stops automatically when you reach the high level, and then that'd be it. So this was for fuel control of a generator. Dan, thank you for the follow, mate. Really appreciate it. There obviously must have been an off mode where if it's in there, no matter what happens with the switches, none of that, nothing would work, which it doesn't appear to be doing. I'm just looking at the relays down in the corner. None of them are coming on, and just to show you again, them pumps aren't coming on either. So there was a key switch on the panel, I seem to remember. So it had a auto, off, and I guess a manual. So let's try manual mode. And we've got a start button. No stop button. But like I say, the software has updated, so it has gone a bit weird. Why have we got no... Ah, the stop button's up here. My apologies. I'm obviously blind. Work on fuel pressure or... No, it would be switches in a tank. So like a fuel tank, it would have a high switch, a high switch, a low switch, and a low. And it would just work off the switches. There was an analog gauge as well, because this panel had a Schneider M221 PLC in it. But what they basically said was they don't want the PLC to do any control, because basically their guys on site, you know, they weren't very good with PLCs. So the PLC was just doing data transfer and stuff like that, HMI and that sort of thing. But the actual control, they wanted to be hardwired, because their guys would be able to fix it or would be able to modify it in the future. Evening, the engineer. How are you doing, mate? Thanks for joining again, buddy. Why do I keep getting this message? Live visibility restricted for 10 minutes. I don't know. Not sure. So yeah, the actual control was done hardware-wise, with relays and timers and that sort of thing. Hi, Paul. How are you doing? What software is this? This is Simu Relay, mate. SIMU Relay. And you'll find it on the Microsoft Store, the Google Play Store, and the Apple Store. Adele, thank you for the follow. Uber, thank you for the follow as well. I really appreciate that. So put it back into play. Yeah, just back into manual then. Start button, stop button. And you can see over here is where the changeover happens. So as long as that day pump start relays on, this will close up here, this K13. It'll then put a supply down. Let's do it. You'll be able to see. Goes through this pump change relay, which is a changeover contact, and they are the actual pump start relays to actually start the pumps themselves. And this changeover, this pump change relay, is what does the changeover between pump 1 and pump 2. Which is this one here, which is something called an impulse relay. I don't know if any of you have ever used one of them, but basically, for every positive edge, it'll transition, it'll change over on each. Basically, every time that closes and opens, this will either energize or de-energize. And by doing that, you get this changeover here. So I wonder if I can show that. Let me try and make them closer together, because, like I say, I think the software updated between me building this, and it's all gone a little bit funny. And it looks awful. But if I bring it in closer, you might be able to see it all together. That restriction happens when people sit spamming the like, mate. TikTok thinks you're using bots. Ah, is that right? I mean, I don't feel like we've got that many likes in. I've been on half an hour. Sometimes they kick you off live because of it. I had it twice. I had it at the start as well. It's a bit odd. I mean, I guess I'm not moving, but I don't feel like anyone else really moves a lot on lives. I'm not going to start doing star jumps. Yeah, I'm going to bring this a bit closer, try and make it look a little bit prettier. I think you guys can see that alright, yeah. Right, that's all a little bit closer. It still looks awful. Let's try and pretty it up a little bit. Can you explain the design for this, I guess, for this? I have a little bit already. I don't know if you maybe missed it. Right, it's all a bit closer together now. So I was going to show you the impulse relay. So that's this relay here. Hopefully you can see that. I think you can. Every time I start and stop. Hang on, I need to go in manual mode. If I stop that, it stays energized. Do you see it? It's latched in. If I start again, it should go off. Which it didn't. Let me see that again. Oh, it went off there. Oh, maybe it's on the falling edge then. Start, stop. Yeah, it's on the falling edge. So every time... so it's the falling edge of the pump circuit. See, I have trouble remembering it. I designed this years ago. Yeah, so every time the pumps are told to stop, this opens up and then closes again, I guess. Let's just watch it. So it's open now. When it closes again, that's when this relay will go off. And if you look over here, I think you can see that. No. This is the contact I'm looking at. This is the changeover contact for the pumps. So you see that changeover. Start it again. When I stop it, it should change over again. Yeah. Let's get a bit closer so you can see that. So stop it, it'll change over. Start it, it stays where it is. Stop it, it'll change over. Start it, stay where it is. And so on. And that's how it's changing over these two pumps over here. So you can see that just about. So there's pump 1 on. If I stop it, start it again, pump 2's on. Stop it, start it back to pump 1. And just doing changeover like that. How do you get into controls? Did you start off in a maintenance type job? I didn't, but I think that's probably the best way to get into controls, to be honest. If you're like an electrician or something, I think that's probably the best way to do it. I did an apprenticeship at a manufacturing company who manufactured control panels, and as part of my apprenticeship I just picked it up. The engineer, thank you mate, really appreciate that. Oh, I missed some earlier. Ralph Salmon, thank you, I missed that, I'm really sorry. Tay, I also missed that, I'm really sorry. Ralph, I missed your first one, I'm really sorry. And Chloe as well. I do apologise for all that, I did miss them, I don't know why. Do you do tutorials for function block programming on PLC? Not really. Cheers, buddy. I really appreciate that, the engineer. I don't do tutorials or anything like that. I just kind of come on here and do what I really, what I think would be interesting and what I want to show, really. I did do a live, maybe last week, using function block diagram, using a Schneider Zelio smart relay, and that was in function block. So have a look. After every stream, I'll put the lives on YouTube. Might be like a day or two later, but the full live will be on YouTube, on my channel. So if you missed that, have a look on there. What would you wish to alternate the pumps like that for? For what application? It's just to basically reduce the amount of wear on a pump. So you could have it where you just always run one pump, and if that failed, you change over to the other one. But alternating it basically reduces the wear on pumps and keeps the wear even on both of the pumps, really. What's the software? It's called Simu Relay, mate. It's a master and a standby. It's kind of not. It's not quite like that. In reality, I don't think I obviously didn't put it in here, but in the actual control panel that we built, if this one failed, it did change over. So there was a master standby. This one kind of isn't, because even if that failed, not that I can simulate that, I don't think it would change over on this, I believe. Not that I can remember anyway. It was just dual pumps, and they both alternated to keep the wear down. Thank you, David. Really appreciate that, mate. Thank you. Maintenance on the pump while still running. Yeah, that's another aspect of it. So if you wanted to do maintenance on day pump 1, you could just chuck it quickly into manual, press the stop button, then the start button. Then it'd go on to 2. You could then maintain pump 1. No, the other only kicks in after every stop. I don't fully remember the reasons why. This was all sort of customer led. You know, they had a spec. I had to follow it. I designed the circuit to make it do it. Can you put an oscilloscope to see the waveforms? Not in this software, mate. No, this doesn't have an oscilloscope. Would you show how to wire and connect to each device? I can. Yes, I can, Ralph. No problem, mate. Let's do a new one. I don't need to save that. So if you're using this software, you can use either AC. I don't know. Yeah, you can see that kind of. There we go. So you can choose your power supply. You can either have like a separate positive and a separate negative for like DC control. You can have separate L1, L2, you know, for AC control. You can have them all separate. Oh, I nearly knocked my camera over there. You can have them all separate, or you can pull in these all together ones, like, you know, L1 to L3 and neutral. And I tend to just use the battery just because it's easier. I don't have to mess around then. If you want to hook them up, so let's put a push button in. If you want to hook them up, you see there's these little squares here. So let me get a bit closer. There's these squares on the end of each component. You click that once, and then you find the other square you want to connect to, and you click that, and it just makes the connection for you. Sometimes it'll put the wire in a weird place, so you might have to drag and move it. But yeah, that's it. It's fairly straightforward. Sometimes I find it doesn't really want me to connect two things together in the way that I've aligned it. But you can get around that by pulling in these, like, they're basically a line with two connectors on the end, and you can then, you know, connect stuff up however you want and move it around and that sort of thing. So that's always an option. No problem, mate. Yeah, no problem. Let's have a look at, don't save that. Let's close that down. What else do I have? I have a pump control one. I feel like I did the video on this. I did. I made this for a video probably about a year ago. Again, it looks to me like it's all gone a bit weird. The software has updated since, and everything's kind of changed a little bit. Oh, I was going to show that next. Never mind. There we go. Can you see that? There we are. So this was a pump control. See, it's looking awful. I hate softwares that when they update, they break older stuff. I guess that's just part and parcel of it, but it's a little bit annoying. So they're not supposed to be there. I'm fairly sure they would have all been in a line, all these wires, just to make it look nice. What's that there? That shouldn't be there. That should be there. 1 second. I'll run it in a second and we'll go through it. So this one was a duty assist pump control. How weird. I've got the same design. You have this design. I built this myself. It's a pump station. Mine has gone weird since Simi Relay updated. Yeah. This is a duty standby. It's a duty assist. Look at that. Yeah.
You must run control.
I don't know. I think it's the design engineer in me. It just kind of winds me up seeing wonky lines and stuff like that. Like, why is that not lining up anymore? There we go. It has lost the positive though. Can I undo that? No. Jeez, where's that positive go? Hang on. It hasn't lost the positive, it's there, hiding. Yeah, I think it's the design engineer in me. I hate to see lines that... See, like this here. they should line up, and they're not. And it's, yeah, frustrating. Right, so let me turn it on. Isolator, fuses, that turns my power supply on. So my AC fuses are closed. Turn on my DC. See the colours start lighting up. Dima, thank you for the follow, really appreciate it. Turn my fuses on for the pumps. Do I need... No, I don't need to turn them. They're the contactors. I think we're good. Ah, the start. Ugh, sorry, I'm sorry. I just can't bear the sight of it. Right, there we go. That's better, I think. What's going on over here? That's okay-ish. Well, I'll live with that. I'll live with that. Right, let me turn the stuff back on. That. Those two. Right, there we go. So, how did this work then? There's a start float. I guess that's got to be closed. Now, the stop float needs to be closed first. So, then there's a start float. It gets the duty pump running. So, whatever, you know, whether we're emptying a tank or filling a tank or whatever, that pump started going. It's activated the... Let's say we're emptying or draining a tank. If we're draining it, and you know there's a constant fill on this tank, but we're trying to drain it, this pump's pumping out the liquid, whatever that fluid is. If at some point while we're pumping out this fluid, it's still filling because the input is greater than the output, genuinely this is sewage. Let's talk about sewage then. Yeah, let's just... Right, so if more sewage is coming in than is going out, that's what this second pump's for. It's called an assist pump. And the assist float would then close, and both pumps would then start to get rid of the sewage. This is in auto mode, so it's all done on floats. So after the assist, you know, we've dropped the sewage to a level where we don't need the assist, that would go off. That float would go off, but it wouldn't actually go off until the stop float went off even. Let's put it into manual, which I think is that position. 2 is off, 3 is hand. Let's put the stop float back on. So in hand, it just always runs. There's no real control. What else we got in here? Oh, we've got some overloads and stuff. I can show them, I guess. The assist comes on. Yeah, there must not have been any push buttons. I don't remember really what I did on this. I remember I made a video on it though. So let's bring the assist on. That brings that one on. If one of the pumps, in fact, yeah, if one of the pumps was to trip out, it would trip everything through the fault relay, because down here the assist pump has tripped. That goes through to the fault relay. The fault lamp comes on. If we were to then fix the overload on that pump, is it called a jockey pump? Not entirely sure, mate, to be fair. This isn't the sort of thing that I work with. However, I wanted to make a video on pumping, so I put this together. I can fault reset it and it will all start again. And if I had the other one trip, it will go off again. And that's because we're in hand. If it was in auto, it'd have to wait for the float once more. So let's fault reset it. The start float would have to come on. My assist float's already on. Yeah. Dima, thank you for the follow. I don't know if I said that earlier. So that's another circuit I've got, yeah. So have you used this before then, the engineer? You must have. Freddie, thank you for the follow. Really appreciate that, mate. I wonder if I've got any other circuits worth looking at. Not entirely sure what this is. Let's run it and see. Close. It's gone funny again. I must have had some buttons over here. I think I was simulating a circuit breaker in this. Let me just sort them wires out again. Yes, mate, it's the most common one in my industry. You lot for sewage pump station. No, sorry, I meant the simmer relay. Have you used simmer relay before? Water pump stations. Ah, see. So, yeah, maybe I looked at something, looked at a drawing or something I had to put that together. I can't really remember. Just checking for any weirdness. There's another one. Right, okay, let's play that. Can you see everything? It's probably going to go a bit small. There's everything. Press that on. See the breaker closes, the lamps come on. Open that. And then if it tripped, obviously it can't close if it's tripped. It goes off. The open comes on. Ah, that's through this. Okay. I'm figuring it out myself. Yeah, it's pretty good, mate. Yeah, it is pretty good. I have no idea when I put this together or why. I guess maybe I was going to do some test rigs or something like that, maybe. Yeah, so that's really, I think, all I've got on Simmer Relay, really. Air handling system on a roof. You can have two and it changes over to give one a rest. Is it? Oh, the pumps we're talking about. Welcome in, everyone. Thank you for everyone who's liked the live, by the way. Okay, so yeah. I had a few circuits that because this is a new computer, I haven't really got much on it, but I pulled some stuff off OneDrive that I had from ages ago, so I think Matt did the same design a year or so ago, can't remember his TikTok. Yeah, I'm not sure who that is, mate, yeah. I did that video probably about a year ago as well. Yeah. What program are you using and cost? It's totally free. It's called Simmer Relay. The other thing I was going to show tonight, we're getting near the end now, was this software, which I don't know if anyone's used. I mentioned it earlier, Schneider M221 PLC, but the software for that's free. It's not bad. You can simulate in it and stuff like that. The only downside is you can only write in ladder logic or instruction list. Let's do the old bog standard that I always do. You're probably sick of seeing now, but just a little latch circuit. Let's just put M0 in there, M1 in there, M2 in there, and then M2 in there. I should be able to put that in simulation mode. Can't remember which button it is. I think it's that one. No, simulation mode's that one. There we go. When you say Matt, the engineer, did you mean Matt Ortledge? You mean Ledge approved? Is that who you're on about? I was wondering. I was trying to think who do I know that's called Matt. Turn that on. Latches up. Job's good one. Yeah, the M221's pretty good. Yeah, that's him. Yeah. I didn't realise he'd done that. Yeah, I didn't know. I wonder if I've seen that video. I'm not sure. Yeah, Matt's got a good channel. He doesn't post as much now. I wish he posted more. Edwards, thank you for the follow. Really appreciate it. Can you guys see that all right? Do I have to zoom in? No, you can't see that now. See, the problem with TikTok, which I find, is the portrait makes it very difficult to show stuff clearly. That looks alright, doesn't it? So there's a standard latch. Let's come out of this. Let's do a couple of analogs, because you can simulate analogs and stuff like that. So let's say if D percentage, isn't it? And it's MW, not D's. Still used to Mitsubishi. If MW0 is greater than, let's say, 200, then let's turn that on. But if it's only if it's less than %MW0 less than or equal to 600. Let's say that. We'll put on M3. Put that in simulation mode. IDK, thank you for the follow. Really appreciate that. Set to run. Where is my analog? Normally it comes up on the screen when you simulate with well, never mind, I can do it with a animation table. %MW0, and in here I can say 100. So I think you guys can see that okay. Sergeant Sarcasm, thank you for the follow, really appreciate that. This software is called EcoStruxure Machine Expert Basic, and it's the PLC software for M221 PLCs, Schneider ones. User 45, thank you for the follow, really appreciate that. So yeah, 100 obviously doesn't cut it, 150 doesn't cut it. If I get to 199, still doesn't come on. I'm just looking at this M3 here, and if I get to 201, you can see it comes on, and it will stay on providing I'm between that band of 200 and 600. So if I put 300 in, still all good. 400, still all good. 500, still all good. 590, still on. M3, still green. If I go to 600, I think, yeah, we're still good, because it's 600, it's less than 600 or equal to 600. If I go 601, then it goes off. I'm a bit disappointed, because normally you get like a little slider to pull about when you're doing simulation. I don't know if it's because I've got it like half screened that it's just not there. Never mind. This is Machine Expert Basic. It is Leicester. It is, mate. Yes. Yeah, notice he hasn't posted much. He helped me with some VFDs. Nice guy. Yeah, I like Matt. Matt is a good guy. Yeah, I like his videos as well. He doesn't post as much anymore. He puts a lot on his stories still, and that from his, like, you know, his memories and that sort of thing. But yeah, he's got a good channel. So then if I keep going up, 800, obviously it's not going to come on. It has to be between the band of 200. Ah, here we go. I found my little thing. I've got that message again. Live visibility restricted. I don't know why it keeps doing this. I'm not sure. Yeah, so if I go back down between 200 and 600, so say 400, it'll come back on. What are those instructions on the second rung and its functions? These are comparisons. So if I come out of simulation mode, you can see the comparison is, or hopefully you can see, maybe I'll zoom in. There we go. If %MW0, which is a register within the PLC, is greater than 200, it will allow logical true to flow through it. If %MW0 is less than or equal to 600, then it will allow it to pass through there and eventually energize the coil. Is it a free software? This is free software, mate. Yeah. So they're just comparison instructions to compare an analog value, or you know, a value 200, to what's in the register. So if I just come back out, you can see that okay, I think. Yeah, I have to make it crazy small. Let's pull that across so you can see it a bit better. So if I put it back into simulation mode, and if I pull over this thing, I double click on that, I get this up. That's what I was looking for earlier. So, in fact, no, wait a second, guys. I need to map the analog input to that register so I can use it. So let me just insert a rung here. Put a contact, call it S12, I think, run mode, so it'll always run. And then an expression over here that says %MW0 equals to %IW00, I think it was. So basically what this expression is saying over here is the MW0 register. I think you can see that. I don't know. Hang on a sec. You can see it a bit better now. The MW0 register. This is like the move command. You know, like on Siemens or Mitsubishi or whatever, you get move. So we're moving the value of the value that's in IW0 into MW0. So that's just what I'm doing there. I think if I move that back, put that there, you can see it. I'll go back into simulation mode. Good stuff, good stuff. Where and why would you use that comparison, mate? I've used that for... The first thing that comes into my head is temperature control. I've used it where I want like a heater to come on at a certain temperature and only go off at a certain temperature and that sort of thing. That's what's coming in my head. I can't exactly remember why I did it that way, but I did. And also, you might latch up this low end one. So you put like a contact in here of M3. And it can only be broken by this comparison here. What software is this? This is Schneider EcoStruxure Machine Expert Basic. Bit of a mouthful. If you just Google Machine Expert Basic, I'm sure it will come up. It's the programming software for Schneider PLCs. Or M221 PLCs, that is. So let me just put it back into simulation mode. Get my fancy little slider up. And we're in run. So now, I don't know if you can see that, but as I move this slider, the value of that register is changing. Let's zoom in case you can't see that. Can I zoom in? I seem to have lost my ability to go down. Oh, across. There we go. Let's pull that down a little bit. So you should be able to see that register moves as I move the slider. And as I go up, if we get past 200, which it is, well, you can't see it, but this %M3 will be on. It's a bit of a nightmare, is this software, to get right on the screen. And if I go above 600, it will go off again. It's basically creating a dead band. So that the M3 bit will only operate within that dead band. So depending on the level of the analog signal, you know, it'll go up, down. But if once it gets inside that band, that's when it's, you know, true. It adds a bit of hysteresis for you to, you know, a working analog value to work within. Hopefully that makes sense. I don't know if I'm explaining it very well there. I think I've answered all them questions. So it's about 10:15. I'm probably going to end it there, I think. It was only going to be a quick one tonight. I came on a bit late. Also need to look into why I keep getting my visibility restricted. Not sure what that's about. Yeah, so the engineer, thank you for them gifts tonight, mate. Thank you to everyone who's followed. Thank you to Danny Sav for being mod tonight. Yeah, I'll probably live stream tomorrow, I'm thinking. That's when I'll be next on. I'm not sure what I'll look at yet, but we'll figure something out. So again, thank you everyone for joining, and I'll see you tomorrow.